Welcome back to Science to Sleep By. Tonight, as the world gradually quiets down and the stars continue their silent journey overhead, we'll explore one of the most fascinating ideas ever imagined by science. It is a concept that appears in movies and novels, yet it also emerged from the mathematics developed by some of history's greatest physicists. This is the story of wormholes. As you settle in and relax, there is no mystery to solve and no puzzle to rush through. We'll simply follow the ideas slowly and peacefully as generations of scientists have done. Together, we'll discover what wormholes are, where the idea originated, and whether these strange tunnels through space and time might truly exist. So take a comfortable breath, let your thoughts drift gently, and join me for tonight's journey into one of the deepest questions in modern physics. Long before the term wormhole became popular in science fiction, physicists were uncovering a new understanding of gravity itself. In 1915, Albert Einstein introduced the theory of general relativity, which revealed that gravity is not a force pulling objects together in the traditional sense. Instead, massive objects bend the fabric of space and time, creating curves that planets and stars naturally follow. This revolutionary picture transformed our understanding of the universe. Suddenly, space was no longer a rigid stage where events simply happened. It became something dynamic and flexible. Matter could shape space-time and space-time could influence the motion of matter. The equations Einstein developed proved remarkably successful, predicting everything from the bending of light around stars to expansion of universe itself. Only a few years later, physicists Albert Einstein and Nathan Rosen investigated a curious mathematical possibility hidden within these equations. Their work suggested that two separate regions of spacetime might be connected by a bridge. Today, scientists refer to this structure as an Einstein Rosen bridge. Although the mathematics were intriguing, neither scientist proposed it as a practical means of transportation. The name wormhole appeared much later. The term evokes the image of a worm tunneling through an apple. Instead of crawling across the entire surface, the worm creates a shortcut through the interior. In much the same way a wormhole would connect distant regions of cosmos through a path much shorter than ordinary space. Scientists emphasize that this idea originated from mathematics, not fantasy. General relativity permits solutions that resemble tunnels through space-time. Whether nature actually creates such structures, however, remains one of the greatest unanswered questions in physics. Imagine two enormously distant points in the universe. In ordinary space, traveling between them could require thousands, millions, or even billions of years. But according to certain solutions of Einstein's equations, spacetime itself might fold in a way that brings those distant locations surprisingly close together. A wormhole is often described as a tunnel connecting two mouths. These openings could exist in entirely different regions of the universe. Some theories even suggest connections between different times or perhaps different universes. Though such ideas remain highly speculative. The concept becomes easier to picture with a simple analogy. Imagine drawing two dots on opposite ends of a sheet of a paper. A tiny creature living on the paper would need to travel across the surface to move between them. But if the paper were folded as the dot touched, the journey could become almost instantaneous. A wormhole represents something similar, except The folding occurs within spacetime itself. There is, however, an important challenge. Theoretical calculations indicate that ordinary matter would not keep a wormhole open. Gravity would cause the tunnel to collapse extremely quickly. Physicists such as Kip Thorne and others have studied the possibility that exotic matter, substances possessing unusual energy properties, might stabilize a wormhole, yet no such material has ever been observed in the necessary quantities. For now, wormholes remain mathematical possibilities rather than established realities. No telescope has detected one, no spacecraft has encountered one, their existence remains uncertain. Nevertheless, scientists continue to investigate these ideas because studying extreme possibilities often lead to deeper insights into gravity, quantum mechanics, and structure of reality itself. In recent decades, wormholes have become subjects of serious scientific investigation. Physicists are not searching for them because they expect interstellar travel tomorrow. Instead, wormholes provide valuable clues about the fundamental laws governing the cosmos. One of the most profound mysteries in science involves reconciling Einstein's theory of gravity with quantum mechanics, the framework describing the microscopic world. These two enormously successful theories work beautifully within their own domains, yet combining them into a single unified description remains an unsolved challenge. Some researchers have discovered surprising connections between quantum entanglement and wormhole geometry. Entanglement describes the remarkable relationships that can exist between particles where measurements of one are linked to measurements of another. Certain theoretical models suggest that these quantum connections and spacetime bridges may be related in unexpected ways. Physicist Joan Mendelsina and Leonard Susskind proposed a famous idea summarized by a phrase ER equals EPR. Though highly mathematical, the proposal suggests that entangled particles and Einstein-Rosen bridges could represent different aspects of same underlying reality. This remains an active area of research and is far from settled science, but many researchers find the possibility intriguing. Meanwhile, astronomers continue observing black holes and gravitational waves with increasingly sophisticated instruments. Although no evidence for wormholes have been discovered, scientists have explored whether unusual signals could someday reveal their presence. What makes science remarkable is its willingness to investigate possibilities while maintaining healthy skepticism. A hypothesis may be elegant and mathematically consistent, but evidence ultimately decides which ideas describe nature. Wormholes occupy that fascinating boundary between imagination and observation, encouraging physicists to ask ever deeper questions about space, time, and the hidden architecture of the universe. The dream of crossing unimaginable distances in moments has inspired generations of storytellers. Films and novels often portray wormholes as cosmic highways connecting stars and galaxies. Yet scientists approach such possibilities with caution. At present, there is no evidence that traversable wormholes exist. Even if they do, the engineering challenges would be almost beyond comprehension. Maintaining a stable passage might require forms of energy unlike anything humanity currently understands or can produce. Furthermore, the intense gravitational effects surrounding these structures could pose severe hazards. Questions involving causality, time traveling, and paradoxes introduced additional complications. Many physicists suspect that unknown laws of quantum gravity may prevent such scenarios altogether. Despite these uncertainties, studying wormholes has profound value. Science advances not only through discoveries but also through questions. Ideas that initially seem impossible sometimes reveal unexpected truths. Black holes themselves were once considered strange mathematical curiosities, yet today their existence has been confirmed beyond doubt. Perhaps wormholes are merely elegant solutions that nature never employs, or perhaps somewhere among the hundreds of billions of galaxies filling the observable universe, these extraordinary structures do exist, hidden beyond our present ability to detect them. For now, the mystery remains unsolved, and perhaps that mystery is part of what makes the universe so endlessly captivating. The night sky above us contains more wonders than any single generation can fully understand. Each answer leads to new questions, and each question reminds us how vast and extraordinary the cosmos truly is. Perhaps one of the most remarkable aspects of wormholes is not whether they will someday become pathways for space travelers, but rather than they reveal about human desires to understand the universe. For more than a century, scientists have used mathematics, observations, and experiments to uncover hidden layers of reality and time, and again nature has proven to be stranger and more beautiful than anyone expected. Wormholes occupy a unique place within that story. They exist at crossroads of some of the deepest questions in physics, touching upon gravity, quantum mechanics, black holes, and even the nature of time itself. Researchers don't study these ideas simply because they are exciting or because they appear in science fiction. They investigate them because the equations of general relativity allow such possibilities and because exploring unusual solutions often leads to entirely new discoveries. Throughout history, theoretical have eventually found support in observations. Gravitational waves, for example, were predicted by Einstein decades before instruments finally detected them in 2015. Black holes, once viewed by many physicists as mathematical oddities, are now known to reside throughout the universe. This history encouraged scientists to keep an open mind while remaining firmly guided by evidence. Even if wormholes never exist in nature, the effort to understand them helps researchers move closer to a long sought theory of quantum gravity, one that could unite the large scale universe described by Einstein with the microscopic world explained by quantum physics. Such a theory might reveal entirely new principles about reality that are impossible to imagine today. As the telescopes become more powerful and observations more precise, future generations may uncover clues hidden among distant galaxies, exotic particles, or the mysterious environments surrounding the black holes. Until then, wormholes remain symbols of humanity's endless curiosity. They remind us that science is not merely a collection of facts, but an ongoing journey of discovery, driven by questions that reach far beyond our everyday lives. And perhaps as we gaze into the quiet darkness of night sky, there is something comforting in knowing that the universe still holds mysteries, for in those mysteries lies the promise that there is always more to learn, more to explore, and more wonder waiting just beyond the horizon of our understanding. As we quietly reflect on the mystery of wormholes, it is worth remembering that our understanding of universe is still in its early chapters. Modern astronomy has revealed thousands of planets orbiting distant stars, detected ripples in space-time known as gravitational waves, and captured images of black holes that previous generations could only imagine. Each new discovery reminds scientists that the cosmos often contains surprises beyond our expectations. In the coming decades, more advanced observatories and space missions may provide clues about some of the universe's deepest mysteries. Researchers hope to learn more about dark matter, dark energy, and the behavior of the galaxy under extreme conditions. These investigations could indirectly shed light on whether structures resembling wormholes are possible in nature. Some physicists believe that a complete theory of quantum gravity, still undiscovered, may eventually explain phenomena that are difficult to understand today. Others suspect that wormholes will remain fascinating mathematical ideas rather than physical objects. For now, both possibilities remain open and science continues its patient research for evidence. This careful approach is what makes scientific progress so remarkable. Rather than relying on assumptions, researchers test ideas against observations and allow nature itself to reveal the answers. Somewhere among the countless stars scattered across the observable universe, there may be phenomena that challenge everything we currently know. And as humanity continue to explore the heavens with curiosity and humility, the story of wormhole serves as a gentle reminder that the greatest discoveries are often waiting in place we have not yet learned how to see. And so, as our journey through space time slowly comes to an end, we leave the question gently open. Wormholes may be real or they may remain beautiful mathematical possibilities. Scientists continue their search guided by evidence, curiosity, and a desire to understand the universe more deeply. Above us, stars continue to shine, galaxies continue to drift, and the fabric of space time carries on its silent dance. Perhaps somewhere in that immense cosmic ocean, secrets still await discovery. Until then, rest peacefully, let your thoughts wander among the stars, and remember that the universe is under no obligation to be simple. Sometimes the greatest wonder lies not in having all the answers, but in continuing to ask the questions. Good night.